So I'm recording. Understand the concept clearly. It's our first Spark class. Lot of exercises will be there for you. The understanding and your expertise is going to be depending on how much you are going to work on this, because I will give you some samples just to build on the top of those particular samples. Also, completely again new to you guys is that I will show you how to install and create a Spark cluster from scratch on your local machines. So I already did that in this week. Next week we will do that because the Cloudera virtual machine that you have supports only Spark 1.6 and currently the version is Spark 2.4. So you need to create a Spark cluster. So that I will do in the next class. Tomorrow I may not take it. Why? Because the exercises that I am going to give are going to be very heavy for you. So maybe this week completely you will have to practice on this in order to get a handle of Spark. Okay. So please spend some time if you want to get expertise in that. This is not a necessary for you. If you are feeling that Spark is too heavy to take now, you can do it a little bit later. I mean, practicing and getting expertise in Spark. Whatever you have learned so far is more than enough for working in a big data environment. But if suppose you want to go into little bit higher, little bit more into programming side, go into core aspects of creating transformations, you want to be an ETL programmer who uses Spark and Scala, then this session is for you. So if you have worked in ETL, it is a very good place where you can convert all your ETL jobs into ultra fast. You cannot even imagine how fast it can be if you know this very well. So it's all up to you. I have given you the Scala book, you got the Scala environment, you got everything on your machine, correct? So you can practice as much as you want on Scala. Scala book is there in that particular directory, right? So just download it. It's written by the author, creator of Scala, Martin Odersky. It's the book, you might have noticed it, right? Now, let's get into what our whole world is speaking, right? Apache Spark. So, first of all, let's understand some of the things that we have studied, and then let's go little bit backward, understand what are the problems, and then from there we will take it. So I'll just zoom in. Right? Remember the first day class? How we started our Hadoop course completely by running a horse race example, correct? So in that horse race example, I showed you how 12 horses were running. Do you remember that program? Right? We were executing that code and then it was running and it was showing, see, all the horse names were programming languages. First prize Java, second prize Eiffel, third one, right? We have executed that particular code using one laptop. So this is my Mac. We executed the code in this particular Mac. If you write the same thing in Scala, you will write val result equal to. What's the difference between val and var? I'm not discussing the internals. I think you all might have already studied this. Did you? No. Okay, so the more you are telling no, you will be feeling very completely void in the classes. Okay. Var in Scala means that if suppose you create var x equal to something, you can write x equal to 20, x equal to 40, you can change. Val in Scala means that it's a constant. So if I write val x equal to 20, I cannot write x equal to 40. Val is more stronger than var. The reason is that if you declare a variable to be val, that means in that particular program or in that executional context, you cannot change the value of val. But if you are declaring a var, that means it can be changed. If a value cannot be changed, it is called immutable. If a value can be changed, it is called mutable. If suppose you are declaring a variable and if it is immutable, it is functionally safer because other parts of the program cannot change it. You are 100% sure that your variable is very, very safe. It is like making a round shell or a helmet around that particular variable so that the variable will not be touched. And that plays a very important role in distributed programming. Why? When you are executing from multiple computing systems, if suppose you declare a variable, if that variable should not be changed by any of the system, Scala ensures that if you declare that variable to be val, nobody can change it. One very important property of functional programming. So that helps a lot. So in Scala, that is how you will be writing that particular code. And now remember that bottom line, it is one node or one Mac and it is one data set. The 12 horses you are feeding into that particular Mac, it is getting executed. Next. How did we execute that particular code? We have executed it by multi-threading. In Java, I used multi-threading in order to execute that particular code, right? So what I did, that 12 horses, I divided it into 12 threads in the same Mac. I didn't change the computer. On the Mac, 12 threads parallelly was getting executed, correct? So, you can split the data and the threads are going to work independently. Each horse is going to run, correct? And when the result is complete, 12 horses are parallelly running, you are going to combine it. And where did you execute all this code? In one system. But 12 different threads. So is the data is shared? Yes. Is the data shared between systems or the data shared in one system between threads? In one system between threads. That's very, very important, okay? And that's how we have executed that particular code. So come on. Now let us assume that I am going to create 3 threads. So 3 threads means 4 horses each, correct? Rather than running in one computer, now see what we are going to do. This is Mac 1, 4 horses will run here. This is Mac 2 and another 4 horses are going to run here. And this is Mac 3 where another 3 horses are going to run it. So it is same model, but what is the difference? The shared parallelism is now not in one computer, but it is in multiple systems. And your data set is also multiple. An excellent language for doing this, of course, within one system is Scala. Why? I told you Scala is a functional programming language which has got much more features of multi-threading. And remember the library name that I mentioned to you, which is built on the top of Scala. Kafka is written completely using this particular framework, where multi-threading and the features like val, the features in functional programming from idempotence, lazy evaluation, memoizable, parallelizable, all those properties, everything combines together to give you an excellent form to write it in a better expressive language and without any errors in Scala if it is one computer. But now our problem is we have many systems. And how did you solve this? You solved this by creating HDFS. And then you told that I am going to run a map reduce here, a map reduce here, a map reduce here, and I am going to combine the result. So map, 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 and then all the maps are going to give the result, and reduce is getting created, right? So map reduce solved that particular problem. Now let's see whether that solution is good or not. So we are going to run the distributed things in parallelly, right? And please look at this one. I'm going to make it big. Anybody know what is meant by L1, L2, L3? Have you heard about L1, L2, L3?
Okay.
Yes. What is it?
Level 1, level 2.
So let's assume that this is my office room and I have got a rack there, and in that rack I kept all my books. Everything is very important, whatever I'm telling, okay? That this is going to make the concept very clearly. In that rack there are a lot of books. So I'm sitting here, this is my table. So whenever I want a book, I go there, I take it. I took out the book, I keep it back, I take the book. So that's the rack. That is RAM in your CPU, in your computer. So RAM is like a rack, and assume that your hard disk is outside. So temporarily you are going to bring that data or books from outside to that rack, what you frequently use. And whenever I want, I go there and I take it. Okay? This is the concept of RAM. Now assume that out of that the Spark book, Scala book and the Hadoop book very frequently I use. So what I am going to do, I am going to take the 3 books and I am going to keep it on my table. Now I made the things better. Rather than going to the RAM, now I can take the book from here and I can keep it back. Got it? That's the concept of L1, L2, L3 caches. Now, L1 cache, L2 cache, L3 cache. In the table, if I am keeping 3 different places, okay? L3 cache, I think, is the closest, L2 is little bit, L1 is the furthest, and then comes the RAM. So, if you want to bring the data from L1 cache, the fastest, 0.5 nanosecond, imagine the power. So if the data is in the cache, in the L1 cache, that means if it is very close to me, if I bring that Scala book and I keep it here, whenever I want I can take it, very fast. Next level, okay, L2, 7 nanoseconds. I don't know what it meant by branch mispredict, maybe some calculation. So L2 cache, it will not be 0.5 nanosecond, but it is here. But I just need to bend and I need to take it. Little bit, right? And if suppose you want to look at the RAM, it is 100 nanoseconds. Again, nanoseconds. And please look at the next one. If I want to read the data from the disk outside the room, it is. So what is the ratio? About 10 to the power of 8 times the disk seek is slower. And where did you keep your data? And where was it? L1 cache, L2 cache or disk? Where was HDFS?
Disk.
Now you got the complete answer. So if I have a computing model which is not relying on a disk seek but relying on memory, it will be much faster. So if suppose you are going there and Apache Spark and press enter, and if suppose you go to the main page of Apache Spark, right? It is spark.apache.org. What is the first picture that you are going to see there? So now you understood why it is much powerful and better and doing so fast computation, because most of the things are handled through RAM.
So that L1, L2 also same like RAM, they put physical.
But the whole
in
problem
system.
is that L1 cache and L2 cache cannot be 100 GB, 128 GB. It is very small. The technology is going to come maybe after 5 years. We will be talking about Spark, which will be not relying on the RAM, but will be relying on L1 cache and L2 cache. So L1 cache is very, very small. It cannot be capable of, or it will not be capable of loading big data. And we are dealing with big data. So that's the fundamental idea of why this technology is faster. So it is 100,000, 10 to the power of 6 times faster, right? And there are some calculations I have given there. Just you can go through this. No need to go through each and every detail, but you understood. And it is written on the right hand side. Memory is the fastest, disk is the slow, and what is the slowest? The network. It is very pathetic. Wherever I work, the network team, infrastructure team tells that we are connected by 10 gigabits per second network. Have you ever done a calculation? Have you ever calculated? You're all working on all this big data. You're telling that data, you're connecting to the databases. Look, this is, let us say, your Oracle SQL Server or whatever it is, okay? So assume that I am going to pull 100 gigabyte of data. You never pulls 100 gigabyte of data. Your data, even if it is 1 billion records, it is not going to exceed 10 gigabyte. So let's say 100 gigabyte data I am pulling, okay? My speed, as per the network team, is 10 gigabyte per second, okay? And this is my talent or my tool, whatever I want to, right? Where is Vara? And now you are pulling this particular data. Now tell me, what is the calculation? If 10 gigabyte is per second, 100 gigabyte, 10 seconds, right? Can you show me in the world anywhere by going and telling that you can do this particular processing in 10 seconds? It is going to take more than 5 to 8 hours. Why? They don't give you 10 gigabyte. Yes, 10 gigabyte per second, but hardly you are going to get, let me tell you, maybe 500 to 600 megabit per second. What is the solution? Keep this and this in the same subnet. Please understand that. It's architecturally very, very important. If this is 10.10.1.5 is the IP, it must be in 10.10.1. something. Same subnet. It will not be. If it is not, suppose this is 10.4. What will happen? It will go through hops. And then finally it will reach here. It is like if I want to go from here to Orlando, I will go to San Francisco, San Francisco to New York, and New York to Los Angeles, and Los Angeles to Orlando. Why? Important, very, very important. These are the things that you should talk if the things are slow. These are the things you should handle. The architecture that we have created is carefully done with these considerations. hardly that percentage is available. So that is what it is written there. So we have to avoid the network, we have to avoid the disk, and we have to make the computation fast, and that's what they are doing, right? So look at this network, 4.8 years, 7.8 months, 2.9 days. Look at the time gap between, memory, disk, and network, just as an example. Right. So in the big data processing or in any data processing, you should think about all these considerations. It is not like, you just went there and then, you installed a Hadoop cluster and everything starts working. So many things are there under the hood, which you should keep in mind. The latest, if you want to know, is beyond your scope, but look at where the research is going on. So they are creating something called Apache Crail. What is Crail? Crail is using NVMe disks. What is the difference between an NVMe disk and a normal disk? An NVMe disk is also called as a non-volatile memory disk. Acts like a RAM. Imagine the power if you bring it. So that's where the latest things are going on. It is going to be an ultimate thing where you are going to use 100 gigabyte per second guaranteed between your disk and your PCI card. That Ethernet card which you connect, the Ethernet connector, that connector, that PCI, that's called the PCI card, that will guarantee you this performance. So the idea is that you need a good processing. So the people came up, MapReduce, ultimate, right? A simple API, fault tolerant, highly scalable. So Hadoop, MapReduce came in. And please look at that yellow bullet points. So that you by heart. If anybody is asking you that why you need Spark when there is Hadoop, that's the answer. Remember the twinkle twinkle little star exercise. Shuffling the data across the network. Just now we have seen many slides. What is the problem if you use network for data transfer? Disk input and output, where the intermediate files are there. Where is the input data? Where is the output data? Can you ever write the MapReduce output to a file, to a database? Always HDFS and then Hadoop FS cat. Remember all the commands that we have typed. Hadoop FS put before you are writing the code, correct? And you already know these numbers. Reading and writing is 100 times slower, and network traffic is 10 to the power of 6 times slower than the memory, right? That's where Spark came in, which eliminated those issues. Not fully, partially. Fully you cannot. Shuffling the data between the network, you cannot eliminate it. Little bit you can, but wherever possible, it did that improvement. And Spark works on resilient distributed data set. So whole life of your Spark career, you will be hearing RDD a lot. Resilient, if you look at the dictionary, the meaning is written there. It means, spinning back, rebounding. So remember about a rubber band. You can pull it, you can shorten it, but always it will have one shape which can be adjusted, increased or decreased. That's called resilient. Distributed. What does that mean? It can reside in many nodes. Data set, of course, the data. So, if twinkle, twinkle, little star, how I wonder that 4 lines, if I am giving to you, and you are a Spark cluster, rather than you are writing the twinkle, twinkle, little star onto HDFS, you will have Bhaskar's internal RDD contains the first line in memory. Surya will contain the next line in memory, Srinu will contain the third line, and Ravi will contain the fourth line in memory. Understand the difference? Earlier it was on the file system, HDFS. Now if it is in the memory, and if you do the computation, that computation need not do a disk read, because it is already there in the memory. And after doing that computation, if there is no wide transformations involved, then in the memory itself it can contain the result, aggregate it, and then give you back, so that the disk is not touched and there is no network transfer at all. So what's an RDD? RDD is an in-memory representation of the data. Now the beauty is, if suppose I gave you that twinkle, twinkle, little star, and if additional data is coming in, that additional data will get added on to an existing RDD by making it resilient or smaller. That's why the word resilient distributed dataset. Ask around, thousands of people I ask, they don't know what is meant by resilient RDD. It shrinks and it widens. That's why I put the dictionary screenshot. First you should know the literal meaning, right? And then, yeah, this is a repetition of the slide. So, in 2009, distinguished professor at MIT looked at Hadoop, started working on Hadoop, understood these problems. 2008, Hadoop released, remember, 2009 itself, they started in the background the work of creating this in-memory computation. See the vision? And the whole world was just started spinning up working Hadoop. The other group has started that work already in 2009. Even the world doesn't know what is Hadoop at that time. And now we are in a stage that many implementations are already done in Hadoop and they are trying to move to Spark. So today when we speak, there can be alternate technologies based on NVMe, Apache Trail already running, and it is going to be released. That's why always be ready to embrace the new technologies. It is not that we are sitting here, we are studying here, I am teaching you. It is going to be the king tomorrow. That is what we learned in all the courses, right? Whenever such things are coming in, you should have the ability now to go read the quick start, install it and do it. With the next class of how you create a Spark cluster, anything in the world you can do on your system. Basically what I am going to cover is Docker in the next class, which is also getting added into your course. So we are going to create a Docker cluster which will give you the complete fundamentals of containers, Kubernetes, etc. And we will start the Docker cluster for running Spark. So tomorrow if any kind of Spark or Flink or any technology coming in, all you need to install is just run the Docker. No virtual machine, nothing. As a good exercise, what you can do is that you can run a Docker with the real Hadoop also. After that, once you learn this concept of Spark. So, 2009 he started by Mate Saharia, a common visitor in all Spark conferences. I just go there just to see his keynote. And so many students also started coming there. So this year it is in June. So from UC Berkeley, it became an open source in 2010. Then it was given to Apache. 1.0 released, 2015 March 1.3, And today, 2020, if you look, the latest version is 244. Okay? Spark originated at AMP Lab. AMP Lab, as written on the left hand side, algorithms, machines, and people. The set of intellectuals, right? Extraordinary brains. They work there. So, under Mete Saharia, 65 students, they created using Scala this particular architecture called Spark. They got funding and they created something called a BDAS, Berkeley Data Analytics Stack. If you look, whatever is written in the red color is the winner. Relational versus NoSQL, no clear winner. HBase versus Cassandra. Cassandra is having a higher edge. Redis, Memcached, React, these are all the memory-based databases. MongoDB, CouchDB, Couchbase, Neo4j, Titan graph databases, Solar, Elasticsearch, we already know. Compute battles, MapReduce versus Spark, so Spark is completely getting replaced. Streaming versus Storm, no clear winner yet. Hive, Spark, SQL, Impala, all are there. Mahout, MLlib, H2O, machine learning libraries, all are there. One of the things which is not there inside this is Presto, which is the unification engine, which is completely different from these technologies, right? So old big data is like this. So this is Hive, this is Hadoop, this is your HBase, this is your Scoop, this is your Flume. So if Bhaskar is staying in this building and wants to use Scoop, he has to walk over to this particular building and use it. Why? Because all these are different technologies. But these different technologies which are all there based upon Hadoop, what Berkeley has done is combined everything into one engine, telling that no Scoop, no Flume, no Kafka. Kafka is a different one. No Scoop, no HBase, no Flume, no HDFS. All into one. And they called it as a unified analytic engine. And that is what Spark is. So it will be one building with all the rooms nearby rather than 40, 50 different buildings now. So that is what the difference between what you all learned and Spark. So if you learn Spark, everything is there inside that. You don't need to go for Scoop. You don't need to use Flume. You don't need HDFS. Spark can read directly the local file. Imagine, in HDFS, can you read the local file? No. Completely broken, right? How the other computers can read Bhaskar's local machine? Not possible. So Berkeley Data Analytics Stack looks like this. The storage is HDFS, S3, Ceph, Minio. All these can be used as the storage and everything you know now. And there are so many other technologies, we don't have to bother. Mainly what we are learning is the Spark, which is the computation engine. So if somebody is asking you, replace or reuse, what's the answer? Whenever you see a solid arrow which is one direction, that means completely replace. If you see bidirectional solid arrows, that means either or. And if you use dashed arrows, that means it is optional. So Hadoop MapReduce, completely replace it with with Spark. Yarn, you can use Mesos. Mesos is a resource manager which came with Spark. Do you know the reason? Why there is a different resource manager for Spark? When did Spark came? 2009. Yarn came in 2011 or 2012. So at that time, Yarn was not there. They wanted a resource manager. Remember everything about Yarn. So they created their own, that's Mesos. So Spark can work with either Mesos or Yarn. Then you have HDFS, or you can use Tachyon, later known as Aluxio. Hive completely replaced by Spark SQL. Mahout, the machine engine where you run the recommendation algorithm and you showed me that the product is 104, can be completely replaced with MLlib. Storm can be replaced with Spark String. These are all the different lines. So Apache Spark, you can go to Open Hub and see how Apache Spark is getting progress. Open Hub will tell you all the data. So as of December 15, 2017, this is the status, and this is Mete Saharia who created Spark. You can see this particular line which shows that almost all the code in Spark is written in Scala. You can look at this particular URL to learn more. And if you want to see the original paper, remember in the beginning classes I gave you the original MapReduce paper by Google, original GFS paper, now original Spark paper. You can see very nice how to write a doctorate thesis. Just refer to that. You will get the core of Spark from that particular PDF document. Just take a printout and you can read. Hadoop, you know how it runs the job. This particular slide we have seen when I taught you Yarn. You have seen how the containers, resource managers, application master, everything runs together. And in MapReduce, you will always write the output to a HDFS file. And in MapReduce, it will go through lot of shuffling between the computers, between the network, and we are trying to avoid that network and the disk input and output. Spark works mainly on the memory, whereas the other things are working based upon the HDFS and the file system. There is a big community for Spark. You can join it. I remember I told you to join in Hadoop forums, and now you have got another one, Spark forums. Look at the number of emails that are coming every day. Any questions, any transformation questions. I heavily rely on this. Otherwise, getting very good expertise in Spark takes years. So you will need to constantly write questions so that a big community is going to help by answering it, right? A must for developers. And there are so many packages created on the top of Spark. All this you can just go through. These are all the very basic concepts that are there in the Spark. I will show you how to driver, how to do the cluster manager, etc. when we are creating the Spark cluster. And now, Spark can be written in Java, it can be written in Python, it can be written in Scala. We won't look at Java at all, it's enough, we can say goodbye, but mostly we will be using Scala. If you want to learn a simpler language, you can learn Python as well. So here we can start your virtual machine and go to the virtual machine. And type Spark shell and press enter. Before pressing an enter, can you please tell me what shell will tell you? What did HBase shell give you? What did Hive shell give you? It will give you the prompt and it will show you the version. And I told you the virtual machine is very, very old version, which is 1.6.0, and it will tell you and stop at one point where you can start typing your code. So that's the prompt that you are going to see, which means that Spark is completely written in Scala. and you can now type your commands. But if somebody is asking you that is it better to learn Scala for Spark or Python for Spark, what is the answer? Since Spark is written in Scala, whenever you write any code in Scala, automatically Spark can understand it without any extra translation. If you write it in Python, Spark has got a Python translator built to convert it into Scala, which will be a little slow. So, in terms of performance, it will not be visible to you. In terms of actual ideal performance, which is better? Scala is better. Now you go back to your particular deck and I want you to copy the middle one. You are creating an RDD. Please understand first what you are doing. You are creating an RDD. And whenever you are creating an RDD, you are using an already created object which is coming with Spark Shell. You can read that line where you started the Spark Shell. What is the last line before the Scala prompt? Did you see? Spark context is available as SC. There is a line there. Yes or no? On your screen. That means SC is the variable that you are going to use for all your code. It is like a servlet context. It is like a context in which you are going to work. So anything you want, you can just write SC dot provided you started Spark Shell. If you write a Java program separately or a Scala program separately, will the Spark context be available? No. You have to create it. Understand the difference? Here you don't have to create it. Why? When you type a shell, automatically the Spark context is created by the shell and gives it to you. Take this and use it. So where this particular way Spark Shell is useful to you, whenever you want experimentation, trying to see whether your command is working, what is the output that you want, then you will use Spark Shell. Once you type and see, oh, okay, this is working, okay, very good. Now I can write the program. Then you will write a separate program that we will see later. Currently, whatever I am talking to you today and whatever you are exercising this week, you exercise completely on Spark Shell. Okay, so sc.parallelize, and then we are going to parallelize a list using Scala. Okay, and let us type that particular command. So how will you do that? Go to your command prompt. Val, already you know what is meant by val. What is val? Val is a constant. Okay, x equal to, if you want words RDD, you can write words RDD. SC dot. Anybody who is having a doubt what are the methods in SC, press a tab. It is going to show you everything that is possible with SC. From day 1 onwards until 2-3 years, whenever you are doing the Spark program, you will get the complete picture, just like Java. Whenever you have a class and if you put a dot, you will see all functions, right? The similar way, sorry. So, val x equal to sc dot parallelize, right? A list. Yeah, whatever you want. Apple, mango, something. And look at the beauty of Scala. Scala is telling you that X is created and X is an RDD of type string. Please understand clearly the meaning. It is an RDD of type string. Can anybody tell me, have you ever written this particular code anywhere? When? Pascal and Martinorovsky's a Pascal lover. And you know what is the beauty of this line? Immediately, the readability, the expressiveness. X is a variable of type int. How did you write in Java so far? Ah, see that reverse. So it is completely opposite. It gives you more expressiveness. Remember one of the properties of functional programming. So what is the meaning of this line then? X is of type
String.
RDD of string. Remember, never use in Scala the word array. The symbol is not an array in Scala. You should read this as a type. In Java, do you know what is meant by templates? That's what Scala is. It is not an array. So it is an RDD of type string. What is that org.apache.spark.rdd? The package name. Remember com.bhaskar, com.ravi? The package name. And what type of RDD it is? It is a parallel collection RDD. There are so many kinds of RDDs. Don't bother about all these things. And type X, you will get the type, whatever it is there. X.count. Hey, where is that left bracket and right bracket you used to keep for the functions? No need in Scala. Whenever you write x.count, it will understand whether it is a function or not. So you don't have to put a left bracket, right bracket, etc. Okay. How about this? You are into your Spark code. So now on one machine, it is creating the in-memory object. So can you please tell me now, please listen 1 minute. Assume that this is not a virtual machine, this is 100 machines. And when you write sc.parallelize and big data you give as a bracket list of, let's say, what will happen? Distributed data set which is residing in multiple machines will be created in memory. Are you getting the difference? But don't say that whenever you write the word parallelize. When you write parallelize, it is always created on
One machine.
one machine. Even if you are running that code in 100 node cluster. So never ever use parallelize in a production environment. Okay. Why? It is going to bring all the data into one machine, correct? So if when you write sc.parallelize and if you give 1 million data, that sc.parallelize will completely create into Bhaskar's machine and then it will create it even if it is a 100 node cluster and it will give you out of memory because it cannot hold that RDD. Understand? So not advisable. Then where you will do it? Testing. I told you the shell is for experimentation. All right. Go back. What is the first one? Python, right? So how will you do Python? Okay, go back there. Close by pressing Ctrl D. Any shell, whether it is a Hive shell, HBase shell, or Presto shell, or this shell, Ctrl D will close it. Okay, clear the screen. Type by Spark. And now you see the prompt is completely different. The Python prompt has come to you, right? And please look at the syntax difference, and I'm not good at that. Okay? And look at the way the syntax is getting changed. You have to type appropriately because now you are typing Python. And please listen. Even if you copy, 1 minute, whenever you are copying some Python code, if the Python code you saw in a website which is containing 4 lines like this, and you Ctrl C and you pasted it, right? Even though it is exactly same, after this prompt, it will not work. It will give you an error. Why? Python is a little naughty language. What I mean by that is, indentation is very important in Python. So when you write like this, next one should be like this, next one should be like this, all in the same line. If I write a for loop, the next one, if you start here, under the for loop, next one should be here. It should not be here or here. Please remember. In Python, indentation is very, very important. So can you copy the Python code now? And then write words rdd.count. See? Did you see the difference? That's what I told you, that Python is not a strongly typed language, and one of the reasons why I am not much a fan of Python. Why? Here you will write val. You declare the variable, right? Here you don't have to write any type, anything. Just write whatever you want. Got it? Right.
I don't have PySpark.
Putty? Sorry?
I don't have PySpark.
You should have. Type clearly PySpark. Can you just check who they are, what he typed?
I did it fine.
It's not possible that he doesn't have PySpark because it is the same virtual machine that I am using.
No, did I?
You made a mistake?
Oh, it's lowercase. I thought the dash was capital.
No.
Oh, sorry.
It's not possible that because it comes with the virtual machine. Yeah. All right. How will you read an HDFS file now into your Spark? Please go back. Control D. I'm coming out of Python. So you understood how to use Python. Wherever you want, you post. It's up to you because it is a language which you can use whatever way you want. And now, please type Spark Shell, which will. So remember, Spark Shell is for Scala, PySpark is for Python. All right. Open another terminal. Hadoop fs minus ls. Let's see whether any directory is there. Oh, so many are there. Input. There is an input. Hadoop fs minus ls input. October 5.txt. Hadoop fs minus cat input slash oct 05.txt. I'm just checking what is existing. Okay. Yeah, apple, banana, grape. I think we have written it for partitioner example. So input slash oct05.txt is a file. Correct? sc dot text file in bracket input slash oct05.txt. Ever imagine that you're reading that complete HDFS in one line? Look at that one line. sc dot count. Oops. Oh, sorry, I didn't declare a variable. Val x equal to, now it's an RDD, x dot count. There are two lines. Just now you have seen there are two lines, right? Can you tell me if suppose I take each word and then I do a reduce by, and then find the sum, what will happen? It is your word count. So how many line more you will write for finding that total count? One more line. So how many lines your entire word count program in Spark?
2 lines.
2 lines. How many lines did you write your MapReduce program?
30, 20, 30.
And that's the beauty. Elegant, very nice. And now you don't have to declare that variable. This is the beauty of functional programming, right? So what I can do, I can write that first one dot, right? And that is how, remember that assembly line? No, don't remember. Huh? Yesterday, Coke bottle, everything I told you, no, Bhaskar? Huh? When that line is coming, I gave you the book. That's why I told you to practice. So, se dot, text file dot, get each word, comma, 1 dot, reduce by key. How many lines MapReduce program is? 1 line. You will really love it. If you are going in detail, you will start the beauty of this language. So amazing. And now you read a file from the Hadoop file system. Now see what is going to happen. What I am going to do is, I am going to open the command prompt one more time. I am going to create a directory, mkdir myspark, okay, just one directory, and cd myspark, and vi hello.txt, and I am going to write hello world, goodbye world. I wrote 4 lines now. And now I am coming back to this one, se.text file. I am going to prefix the word file, which means that it is not from HDFS. 3 slashes, home, Cloudera, which is my home directory, slash myspark, slash, what's the name of the file?
Hello.txt.
Huh?
Hello.txt.
Is it hello.txt? Yeah, correct. Thanks. Hello.txt. Huh? Now you read a local file system. How is it possible? In big data, in MapReduce, were you able to read the local file system? So now what does that mean? No need of? No need of HDFS. See how they killed the Hadoop.
It's tilde file colon.
Yeah.
Why is it tilde?
File. This is the protocol. Now slash home slash Cloudera. That is why 3 lines. Right?
Oh, the tilde, there's a tilde in front of file.
No.
No, it's double quotes, not
Double quote.
Oh,
Oh yeah, the file name, yeah. No tilde, yes. So now you got the file. I think you're not able to see. I will make it because this one is,
oh, that's right.
yeah. So that's it. se.text file, double quote, file, colon, slash s. So whenever you want to read a local file, please give file, colon, slash, slash. All right. So what we can do? All of us like babies, right? Small babies. So, sorry. For our son.com/passion. Please go all the way down and click on Spark Data. in the virtual machine, okay?
Yeah.
Yep, because I need to get the file. Spark data. Right click. And save the file. What's the name? Babynames.csv. And in the My Spark directory, as you can see here, I am going to move that file from the downloads directory right? Huh? Babynames.csv. And look at that, it is a very simple file. There are 5 columns, year, first name, county, sex and count. So 2013, the name is Gavin, the county is St. Lawrence, male, and 9 names are there with Gavin. In 2013, there are 9 names with Levi, and there are 44 names with Logan. Understand the file? How many times a particular name has come? For every county in every year. So you are a data analyst. Can you ask a question onto this particular file? How many people in total born in 2013? Nice question, right? How many people with Levi are born in 2015? Right? You understand? So I want you to write Spark code on the Spark shell to create your own 10 questions and give your own 10 answers. Are you getting what I told? For this data, you can think about 10 questions, right or not? Right? Any 10 questions. For example, you can tell how many people born in New York. Sex M is there. So how many people were male and how many people were female? Understand? You can ask a question that which particular county has shown more counts, right? I'm just throwing up. Yes? But I will help you to get started with. How? Go to again foroursun.com. Where is the file? Yeah. Spark and scala.pdf. Please click on that. Okay, what you'll see. This overview will cover the Spark and Scala with examples. Assumption, you should have babynames.csv, population.csv and county census data.csv. From where you will get all these 3 files? You already saw it, correct? So you know what to do. You'll have to download the 3 files onto your virtual machine local, not HDFS. Forget Hadoop. Next question is that after sparking, after the shell is started, right? Don't worry about the direction, okay? Download all these files. In page 2, I have given the instructions, right? Next. Create an RDD by reading it, and you know how to read it. And please don't copy this. Why? Because it is my directory structure. You have to put /home/cloudera, babynames.csv, and first one names.first. Did you see that? It is printing the first row. We have just executed it, right? Why it is printing that particular first row like that? Because that is the heading in the file, right? And names.count. How many rows are there? 145,571 rows. Correct? That baby names.c is a pretty big file. Next question. What is that? Print line, names.collect, make string, double quote, comma, new line, comma, double quote. What is that? What it will do? It is printing all the names. And what is names? I have used a variable called names. What is names there?
RDD.
Yeah, it is an RDD just now I created on the top. Just go to the first part. Yeah. Follow. What is this? Names I created, right? So, don't type this line without creating the... That's what I want you to practice. What will happen if suppose you don't write that names, and if you write names dot, it will tell you not found. Correct? And next, come down. Don't worry about the scala, this thing. Just come down. You can read through some of the scala there, which is there in the book. I have taken that from the book only, right? So if you want some of the things in scala, just to go through that. Then directly you can come back to question 1. What is question 1? Read the baby names.csv, skip the header, as we don't need the header row for different queries, correct? Because if suppose I am doing a count, if that particular column is available, that is a problem to me. So I want to skip that. So this shows you in ETL, when you have a CSV file, how to skip the header. Right. So how will you do that? Please look at that code. What is the code? sc.text file. So first what I am doing? I am reading the RDD. After reading the RDD, what is names.first? That is a first row. And if I create the variable called header, val header equal to names.first, an RDD will be created called header, which stores the... Okay. What is the next line? Names without header equal to... now you see the fun of Spark. Names dot filter. What is names? The entire data. Names dot filter. And what is the filter condition? Take each row and check whether row is not equal to header. What does that mean? It will take all the rows which is not header. So what will be there in names without header? All the RDD without the header. Can you please do only that exercise just to make sure that you are all on par with it? I am stopping the recording, right?